Start recording. All right, so the last thing we spoke about was this example up here at the very top of the board. X plus 1 equals 4, and the idea behind this is we are now solving. And how do we know we're solving equations? We got an equal sign. Now, I was very general with the statement I just used. I said, how do we know we're solving equations? Okay? There are many different types of equations that exist. Just to let you, this is not all of them, but I'm going to give you a couple. There are linear equations, there are quadratic equations, there are cubic equations, there are square root equations, there are absolute value equations, there are linear inequalities. There's all these different types of equations. So just because you see an equal sign, you cannot automatically assume that the steps you use to solve this problem will always apply for all of them. However, there are some guidelines, some ways that help us. First thing is first. In this class, from now until towards the end of the semester, we're going to be solving linear equations. Now, what makes an equation linear is the fact that, and I'm going to highlight this, you look at the variable, okay? And the exponent on that variable is a 1. That is what makes it linear. So off to the right here, I can even write an equation like this. Notice I have an equal sign in the middle. I got 3x on the right, 3x on the left, 2x on the right. It doesn't matter where the variables are, and it doesn't matter how many you have. As long as those exponents on the variables are a 1, it's linear. All right, you can even have something like this. X plus y plus z, 3 completely different variables. But if you look, each one is raised to the first power. That means it's linear. And one of the steps that we use to solve linear equations, I'm going to scroll back over to the left now, is right here. It's called the addition property of equality. And what that states, it says that if you have A equals B, in other words, you got an equation with a left and a right side. This property says you're allowed to add anything you want. But if you do it to one side, you must do it to the other side. Okay? Now, this also applies if you wanted to do this. I'm going to write it in a different color here. You can also subtract from both sides, but the only thing is, we ask you, make sure it's the same exact value. That's why I'm using the same exact letter on both sides. Okay? Now, how did we use this property for the example above? Well, I'll just redo the example. Was it x plus 1? Yeah. We're going to solve x plus 1 equals 4. Our goal, whenever we solve, doesn't matter what type of equation, is to isolate the variable. Now, the equal sign separates. We have a left side of the equation. We have a right side of the equation. My variable's on the left, therefore that's the side I'm going to work with. I need to isolate that. So what I need to do is I need to take this positive 1 and I need to move it over to the other side. Okay, that's all I need to do. So the easiest way to do that is you want it to, and this is, I think, an easy way to think about it. You want it to disappear on the left and reappear on the right. But since it's on the opposite side, it's going to have the opposite sign now. So since it's positive 1 on the left, what we're going to do is we're going to subtract 1 from both sides. So what I just did right there is I applied this thing to both sides of my equal sign. I said, okay, I'm going to subtract 1 from both sides. On the left-hand side, I get x. On the right-hand side, 4 minus 1 is 3. Are there any questions there? I know, Jasmine. That's as hard as it gets, honestly. It's all about just following steps. Now, throughout the semester, we are going to learn more steps, And then towards the end of the semester, we're going to have 6 steps on how to solve equations. More importantly, let me be more specific. I'm sorry, I misspoke. We're going to have 6 steps on how to solve linear equations. So sometimes we've run into this situation before, and I know I've been there. I've been there as well, which is I don't even know where to start. Well, my first question to you will now be, what type of equation do you have? See, because if you have a linear equation, you're going to do these 6 steps. If you have a radical equation, you're going to do a different set of steps. If you have a quadratic equation, you use a different set of steps. So the where do I begin is now going to be, what type of problem do you have? Okay? For us, everything's going to be linear for right now, and that's a good thing. So let me give you a couple examples to do. So I'd like you to solve the following. I want you to do x minus 9 equals 13. 27 equals a minus 16. That's a 9. Sorry, sometimes my handwriting gets a little sloppy when I get excited. Okay, are we ready? All right, so for the problem on the left, x minus 9 equals 13. Does somebody want to share their answer?
X equal 20. Hold on, I gave you a hint. 22.
22? Anybody else get? Is anybody else get 22?
Mm-hmm.
All right, so this is how we do it. Let's read it. X minus 9 equals 13. We're going to add 9 to both sides because we want to isolate our variable. 13 plus 9, well, 3 plus 9 is 12. Carry the 1, 22. Michelle, excellent job. Thank you. How'd you focus with all that chatter in the background?
I guess I just been doing it for my second nature.
Good job. Thank you. All right, second equation. It's basically the same as the first. 27 equals a minus 16. Now, the variable's on the right-hand side, but that doesn't matter for us. What matters is we need to find the variable, and then we need to apply some sort of technique. In this case, we're going to add 16 to both sides. So on the left-hand side, 7 plus 6, well, that's going to be 13. Carry the 1. 2 plus 1 is 3, plus 1 more is 4. And on the right-hand side, we just have the letter A. So 43 equals A, or if you want to, you can say A equals 43. You could do that as well. Okay, are there any questions with this?
No.
Okay, perfect. So the last topic we're going to learn is our favorite topic, which is translate and solve. So here's the first one, 3. Oops, sorry. Let me write that cleaner. Three more than x is equal to 47. Now, we already have some experience with translating words into an algebraic expression. Okay? Now we need to take it one step further. We need to solve this. And there's one word, and I'm going to write down a couple of them, but there's one word or two words that means the world to us, and it's right here. Let me highlight it for you. Right there is equal to, I'm going to go back to my black marker now, is our equal sign, which means everything to the left of the words is equal to will be the left side of my equation, and everything after it is going to be my right side of the equation. So on the right-hand side, 47. That's the easy one. The left side is a little bit more complex. 3 more than x. Well, what math operation am I talking about here? Add, subtract, multiply, or divide? Add, and what am I adding?
3, add the x.
Perfect, Asma. Thank you so much. So now we have our equation. We're just going to read it one more time, and then we're going to see if we can apply something. So 3 plus x equals 47. I know my goal is to isolate the variable x. So all I have to do is just subtract 3 from both sides to give me x equals 44. How are we looking?
I had a problem when I think on one of my assignments I just kept the wrong answer because I don't remember, and I don't remember what it said either.
All right, all you got to do is go back into your homework, Michelle, and then go to that problem and click on the Ask My Instructor. And then I'll get an email saying that this is your problem and I can write something up for you. Okay? How about I give you one to do, and then we'll call it a day for this chapter, not a day for class. So here's another example. Same directions, translate and solve. The difference of x and 19 is equal to 45.
You wanted me to say this out loud?
Not yet.
Oh, okay.
Yeah, we'll give some people like a minute.
Okay.
All right. We should be good now, hopefully. So, what are the key words in this problem? Difference, that's one of them. So I'm going to highlight that. Are there any other keywords? Yeah. Yeah, it is equal to. So I know I got an equal sign. On the right-hand side is going to be 45. Now on the left-hand side, we got the difference of x and 19. Well, difference means subtraction. And what am I subtracting?
X minus 19.
Perfect. Bless you if that was someone sneezing. So now all I have to do is just solve this by adding 19 to both sides. So x equals, let's see, 5 plus 9 is 14. Carry the 1. 4 plus 1 is 5. Plus 1 more is 6. Yeah. So x equals 64. You're okay. Are there any questions? All right. So if you're following along in our book, there are 2 more sections in chapter 2, but we're not going to do them until chapter 4. So we are done with chapter 1 and chapter 2. So this is what your test is going to be on later on today. All right? Any?
So let me just make this clear.
Go ahead.
I got a notification today on my Blackboard, but it wasn't from today for you too?
Yes.
Oh, well, not two because I don't. Everybody's not in my second class.
No,
Oh,
the
oh,
test.
he's dropping and stuff.
Hold on, Michelle. The test for me today opens today. It's not due until Sunday.
Oh, okay.
So you do it whenever you're ready.
Okay, because my psychology class took me off this week. I'm just overwhelmed.
No, yeah. Sometimes we will have an in class test. Other times, I make it like a take home test. All right. So chapter three. Chapter three deals with a new numbering set. So I don't know if you've been hopefully paying attention, following along, but all of your answers for all of your problems have always been positive numbers. Do you ever notice that, Todd?
Sometimes.
Every single answer is positive. In chapter 3, we start talking about a new numbering system called integers. Okay? So what I want to do is I want to show you what an integer is first. I'll tell you where they exist out in the real world and everything. And then we're going to go about comparing integers. We're gonna look at opposites, and then we're going to look at the absolute value. So integers are positive and negative whole numbers, including zero. Now on a number line, what we're really talking about here are the positive whole numbers that are on the right, and then negative numbers are on the left. Okay? We see and use these numbers all the time. When we talk about temperature, right? In a couple months here, let's see, we're almost at the end of September. So in about 4 months, it's going to be January, February. And when we watch the news to figure out how cold it is outside, they're going to say the temperature is 15 degrees with a wind chill of -10. So what that means is we are on the other side of zero. In other words, for temperature, it means it's really cold. All right? In nature, you could have a mountain and then at the base of the mountain, you have water. It could be like a lake or pond, I don't know, ocean, whatever. But we call this sea level, which means 0 feet. The mountain could be mile high, 5,280 feet. Notice that's positive because it's above sea level. And then below sea level, our little happy fish. There's our little fish. But because the fish is below sea level, we would say that fish is swimming at -32 feet. So the idea behind a negative number is that it just tells us it's the opposite. All right? It's the opposite of positive. When I talk to when I'm teaching like calculus and physics, I get some physics students. A lot of people think negative means like you're slowing down. And the answer to that is it's a little bit more complex, but negative basically gives us a direction. It tells me am I moving in a positive direction or am I moving in a negative direction? Okay? Now, we can easily compare numbers. So for example, I think we can all agree that if I'm comparing 1 and 10, 1 is smaller than 10. Would you agree? All right. I mean, I'd rather have $10 than $1. Now, to compare numbers, we use inequality symbols. Now, these symbols are always read left to right. And here's the first one. So notice it kind of looks like like an arrow almost without like the stem. We call this less than. And then if I draw the same one, or same thing, just opposite. We call it greater than. All right, so we got less than, and then we have greater than. And if I wanted to compare the numbers 1 and 10, what I want to do is make a true statement. So I'm going to put the less than symbol inside. Because when I read this from left to right, 1 is less than 10. And that makes, for me, complete sense. So this is a true statement.
One of my teachers in the past, I don't know.
They're wrong.
No, wait, listen. You didn't even hear it. Whenever you have a number on the left, a little number on the left-hand side, you always use one that looks like an L, meaning for less than.
Sure. I guess that'll work. Maybe I can find.
Have one on the other side, and that being saying that 2 is less than 1. You're never going to have that.
Yeah, but what about negative signs?
That might happen.
I mean, I'm not saying your teacher's wrong.
Everybody knows that negative numbers are always less than positive.
Right, but what if they're two negatives?
Then the bigger one is less than the smaller one.
Okay, so which one's bigger then? So Michelle, how about this?
Okay.
Here's two negative numbers.
10 is less than negative 3.
How do you know that?
Because that's what I was taught through every year.
Okay, but hold on. Teach me now. Like what would be a really good way?
Closer to 0 than negative 10.
I love the way you said that. And I agree 100%. So here's an example here where we have negative 10 is less than negative 3. Now, the answer to this is that symbol right there. That's our true statement. But now let's visually see why. If I were to draw a number line, okay? I'm going to put 0 there so we know to the right of 0 are positive numbers. But watch what happens on the other side. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, and negative 10. So what I'm going to do here is just plot these two numbers. I'm going to plot negative 10, and I'm going to plot negative 3. So I just put a big dot at negative 10, and a big dot at negative 3. When you're comparing numbers, I don't care if they're positive or if they're negative. The larger number is always further to the right. In other words, if you were to take these two numbers and plot them, whichever number is further to the right is the larger number. So in this case, since negative 10 is all the way to the left and negative 3 is all the way to the right, I know negative 10 is going to be less than negative 3. Okay? Now, if you could just think about that and look at this example. Negative 1, and we're trying to compare negative 15. Well, let's just make it negative 5 for simplicity. Negative 1 and negative 5. If I were to draw this number line again, and just plot them. I know -1 is further to the right, so -1 is greater than -5. Does that make sense, everyone?
Yes.
Perfect. Okay. So, Michelle, when you said closer to 0, I agree with that. That's if you're comparing two negatives. In general, though, if you just remember the larger one's always to the right, you never have to worry about special cases anymore. Okay?
Yes.
Perfect. All right. So now we're going to talk about this word that I was using earlier, opposite. If I ask what's the opposite of -5? I'm sorry, I misspoke. What is the opposite of 5? What you would do is you would just write 5, draw like a little arrow, and just put -5. Because if you think about it, on a number line, if you plot 5, the opposite would be the same distance, just on the opposite side. So it's -5. And what I mean by the same distance, it's the distance away from 0. Okay? But there is one little one that I think we all have seen before, and you know what it is, but maybe you never had to explain it. Could somebody explain that for me? Now, if you need, this is the question. What is the opposite of -5? That's what this is asking. So what's the opposite of -5? 5, right? Now, how many of you have ever seen this situation where you had two negatives back to back? We've seen that before?
No.
Never seen two negatives back to back, Michelle?
If I do, I don't remember.
Okay. Todd, you were shaking your head yes.
Kind of. I'm sure I've seen this before in my other math classes, but I don't remember.
Yep, I agree. So anytime you have two negatives back to back, you were always told back in the day, just make it positive. And the reason being is, what this is asking is, that negative sign on the outside means opposite. And then the negative sign on the inside also means opposite. So if you think about order of operations and doing the work inside the parentheses we have -5. But then outside we have that other negative. And all that's really saying is what's the opposite of -5? Now, I realize sometimes that gets confusing. So for simplicity, what we're going to say is whenever you see two negatives back to back like this, just rewrite the problem as a positive number. And that hopefully clears everything up. Okay? All right. Any questions? Perfect. Now here comes the fun part. The absolute value is given the symbol with those big bars. There's going to be a number written inside. Okay? But they straight up and down bars. Okay? We think of them as grouping symbols when it comes to like order of operations, but more on that in a little bit. What I want to know is, what is the absolute value of 2? Does anybody know? I'm just trying to see if we've seen this before. Say it again.
2.
I agree. What's the absolute value of -2?
2.
Why?
I have no clue.
You were just told it's always positive. Am I correct?
Yes.
All right. So the absolute value of 2, which is example A, the absolute value of positive 2 equals 2. And in letter B here, in the second example, the absolute value of negative 2 is also positive 2. And here's the reason why. The absolute value, and I'm going to write this in red, is a measure of distance. Okay? So if you think about it, if you get into your car, so this is your home. If you get into your car and you drive to, let's say, Target. All right, so here's the big Target building. All right, so you get what you need in Target, and then you drive straight back home. Your car doesn't tell you, oh, you've drove 0 miles. It actually counts up the total distance that you drove. So, for example, if Target is 5 miles away, then that means your trip home is going to be 5 miles also. So you drove a total of 10 miles. And then there's a counter on your car. It's called an odometer. It's in the cluster part where it tells you how fast you're going and everything, your odometer, your speedometer. It never counts backwards. It always goes forward. And that's because we're measuring distance. The absolute value is a measure of distance. So if I ask what's the absolute value of 2, then what you're doing is you're starting at 0 and you're counting how many steps it took you to get to number 2. If I asked you for the absolute value of negative 2, it's still a distance. It's just you're moving in the opposite direction. So no matter which way you look at it, it's always going to be positive, and that's because absolute value is a measure of distance. So now, and I don't know why, but if you're ever out on a date with a mathematician, and for some reason they ask you what's the definition of an absolute value, you would say it's a measure of distance. And then maybe your mathematician date would go, wow, they knew it. Because a lot of people automatically assume it's positive. And I'm not going to push back on that. It is positive. But the big question is, why is it positive? It's a measure of distance. Does that make sense, everyone? Okay?
Yes.
So now we're going to take that and use it to our advantage. And we're going to just start to simplify some problems. Excuse me. So we've already simplified the square root of 2 and the square root of negative 2. What I'm going to look at now is this situation right here, because this one you're going to see. So this is the negative absolute value of 13. Now, earlier I made the comment, absolute value gets the symbols of these vertical bars, and we think of the absolute value as grouping symbols. And what I mean by that is when you go ahead and use your order of operations, you know we always do parentheses first. Well, remember, parentheses can look like parentheses or brackets or these squiggly braces, but now you can also add in the absolute value bar. So when I look at the example on the left over here, the absolute value, negative absolute value of 13, what I need to evaluate first is the absolute value of 13. We can think of this negative sign out front as negative 1 times the absolute value of 13. Therefore, I'm going to evaluate the absolute value of 13 first. Well, that's going to be positive 13. And now I'm going to multiply these two numbers together. Okay? Does that make sense, everyone? Remember, you're doing the absolute value of 13 first. Then you're going to multiply it by -1. Okay? Now,
Would negative ever be in the brackets?
yes, I'm going to do it right now, Michelle.
Okay.
So just to make things a little bit more complicated, watch this. Here's a situation where it looks familiar. We can see those double negatives back to back. But here's the difference. In this situation, I have the absolute value bars. Okay? Which means I have to do that first. So I need to evaluate the absolute value of -7. And the absolute value of -7 is +7. So this negative on the outside, in fact, I'm going to change colors so you can see exactly what I'm talking about. There we go. So these two are the same thing. So I had to evaluate the absolute value of -7 first, which is +7. And now I'm going to multiply -1 times -7 to give me -7. Okay? So the absolute value, or the negative absolute value of -7 and negative quantity -7 are not the same thing. Okay? In the first case, this is equal to -7. In the second case, that is equal to +7. Okay? So they are not the same thing. You need to be very careful with this, because we could easily make a mistake. And
Punctuation that makes the difference, right?
100%. That's everything. So if you write clean and you write a little large, hopefully you won't make those mistakes. All right? Because they are not the same. All right? Are there any questions?
Will this lecture be up on Blackboard?
Of course.
Okay.
All right? So let's end this with some examples here. So now we're going to start pulling in everything that we've learned. All right? We're going to pull in our order of operations, absolute value, the idea of integers. Everything's going to come at us at once. So if I want to simplify this, I have the absolute value of 8 plus 7 minus the absolute value of 5 plus 6. We treat the absolute value as grouping symbols. So I'm going to group them together. 8 plus 7 is 15. Notice I still have the absolute value symbols around them. 5 plus 6 is 11. Notice I still have the absolute value symbols around that. Now, I'm going to do the absolute value of 15, which is 15. We're going to do the absolute value of 11, which is 11. Finally, 15 minus 11 is 4. The only way I think you're going to get these problems wrong, and we are all guilty of this, moving too fast. You're just going to slow yourself down. All right? Try not to do a lot of mental math. Write it down so you can see it. The more you write things down, the better off you're going to be in the long run, and then the mental math becomes really simple. Okay? So here I'd like to give you one to do. This one's going to be tough, I'm not going to lie. Directions are simplify. So you should be thinking order of operations. Try that. I'm going to get a drink of water because my voice is starting to go. Okay, did anybody happen to get an answer yet?
I got 32.
Connor got 32. Anybody else get 32?
44.
44? Anybody else get anything different? All right, let's see what we got. We know we treat the absolute value as grouping symbols. We got to start with parentheses, and we always do the innermost first. So I see 6 minus 2. Do we all agree with that? Perfect. I'm going to rewrite everything exactly how it looks. Except 6 minus 2 is 4. Now, I still stay inside the absolute value because I think of that as a grouping symbol. And inside the absolute value, I have 19 minus 3 times 4. So I have to do 3 times 4. So I get 24 minus the absolute value of 19 minus 3 times 4 is 12. So far, so good? All right, I'm still inside those absolute values. I'm not done with that yet. So I'm going to subtract 19 minus 12. So I get 24 minus the absolute value. 19 minus 12 is 7. Now I can finally do the absolute value. The absolute value of 7 is positive 7. And 24 minus 7 is 17. So, I heard a couple incorrect answers. My question to you is, do you see where you made your mistake? All right, Connor, where did you make your mistake at?
Not rewriting the equation for the second time.
Yeah. So in other words, it wasn't like you didn't know how to do the problem. It was a typographical error. Notation is everything, I think, is what Michelle said earlier. All right, let's do another one. There you go. Very similar problem. Okay. Do we have an answer?
I got 16.
16? I'm going to write it off to the right. Any
17. I get 17.
17?
I also have 16.
16 as well? Okay, so we're getting a couple 16s. Any more 17s? All right, so maybe just a little math here. So let's go ahead. Let's do this. So, got to start innermost parenthesis. So that's going to be right here.
Oh, sweet.
So we got 19 minus the absolute value of 11 minus 4 times 3 minus 1 is 2, correct? All right. So now, I still need to stay inside the absolute value. I'm going to do 4 times 2. So that's going to be 19 minus the absolute value of 11. Minus 4 times 2 is 8. Now, still inside the absolute value, 11 minus 8 is 3. The absolute value of 3 is 3. And 19 minus 3 is 16. Good? Alrighty, we all on the same page so far?
Yes.
Perfect. All right. Well, I'm going to call it a day. We'll leave it at that. When we come back on Wednesday, we're going to go over section 2, 3, and I think 4. What's 4? I forget what 4 is. Oh, yeah, we're going to do 2, 3, 4, probably 5. 2 and 3, I teach together. Section 4 takes me 5 minutes. And then the only one we got to worry about is just solving equations using the division property of equality, which I think you already have an idea. But we'll worry about that on Wednesday. So if you don't have any questions, have a great day.